Hello everyone. In this induction heater project, I am going to improve my induction heater by adding more turns. So as you can see, this is the same induction heater I have made. This is my utensil and I have made now total 20 turns of copper wire, 10 turns of copper wire on the first layer and 10 turns of copper wire on the second layer. So presently I am having 20 turns of copper wire on this utensil. So this is a steel vessel and I am going to oscillate the inductor with some frequency. Before going for an oscillation, I am going to connect a capacitor in parallel to this inductor. So as you can see, this is the inductor and here this is my capacitor. You can see 0.45 microfarad. So this is my capacitor. It is connected in parallel to this inductor. So this is how the inductor is made. You can see here this is the capacitor and here is the inductor. Both are in parallel. So now I am going to oscillate this circuit. I am going to use IGBT powered device. So as you have seen in the other videos, so this is the powered device. You can see this is the heat sink and under is the IGBT. You can see under is the IGBT. So here you can see this is my choke coil. Here is a choke coil and there is a filter capacitor lying here. Here is a filter capacitor. So currently ignore this transformer. This transformer I have made for some other project and I didn't remove it. I just kept it. So as you can see here, whatever voltage I am getting, I am having a variac and the output of the variac is rectified using this rectifier, and here there is a filter capacitor. This is a filter capacitor. So the output of this filter capacitor, before I was feeding to this IGBT directly, but then there I found some issues. I am going to discuss the issues in the circuit diagram. So as you can see, this is my current circuit diagram. Here is the variac, here is the variac, here is the bridge rectifier. So the output of the variac is fed to the bridge rectifier, as you can see. And after the bridge rectifier, there is a 470 microfarad, 400 volts capacitor. So before I was not having this choke coil. So I was feeding directly power to this oscillator circuit. So as a result, what was happening? High frequency was flowing back to this capacitor. Since this capacitor was in parallel to this circuit, the high frequency was flowing back to this capacitor. And since the capacitor value is high, the complete high frequency it was allowing to pass through. As a result, the capacitor was getting very hot. So in order to prevent this backflow of the high frequency current, I have used this choke coil. You can see here, this is the choke coil I have introduced in this version of the circuit. So this choke coil will prevent any oscillation flowing back to the power circuit. Only the power flow will be like this purified flow, and if there is any backflow of high frequency voltage or current, it will be absorbed by this choke coil. One thing to remember is that the number of turns in this choke coil has to be much higher than the number of turns in this vessel. Suppose here I have made 20 turns, then on the choke coil I have to make at least 8 to 10 times number of turns. So at least 160 to 200 turns better to use in this choke coil, the number of turns. So presently let me show you the choke coil. So as you can see, this is my choke coil. So this choke coil is going to absorb all the high frequency voltage or current flowing back from the circuit towards the power supply. So here you can see this is the choke coil. So I have made this choke coil at home. Again, I would like to describe the function of this choke coil. So when the circuit is oscillating, the IGBT is switching on and off. As a result, there is a chance of power backflow, because this circuit is in parallel, this capacitor is in parallel to this circuit. So in the equivalent circuit analogy, both are in parallel. So there is a backflow of high frequency current from here to here. So this choke coil will prevent the backflow of the current. So let us check the performance of this circuit. So this circuit is resonating at a frequency of 48 kHz. Already I have calculated the frequency, resonant frequency, and I have tuned the circuit. You can see this is the induction heater. So let me power up the circuit. So as you can see, I am increasing the voltage from the variac. You can see. You can see 16 volts, 19 volts, 2 ampere. So from the variac I am increasing the voltage 28 volts, 30 volts. You can see. So I will go up to 5 ampere, then I will stop. Here you can see 39 volts across the coil and the current is 5 ampere. So let us see the supply voltage. So as you can see, I am supplying 46 volts DC. You can see. So here you can see the voltage across the coil is 40 volts. So supply voltage was 46 volts and voltage across the coil is 40 volts. I have switched on the fan to ensure cooling in the IGBT. So I can see very good heat is there inside the heater. You can see the heater is very hot and heater is drawing a current of 40 into 5 ampere, so 200 watt. Thanks a lot. Thanks for watching.